Hi there, my name is Vince Harlabidis, and in this video, we will work together some first-degree equations, and more precisely, those cases in which we have variables on both sides of the equation. Let's quickly begin with the first example. Solve 3x plus 5 equals to 2x plus 11. As we have said in one of my previous videos, one of the key concepts that one should do to help him or herself is visualize an imaginary line that can work as a physical boundary between the left-hand side of the equation and the right-hand side of the equation. As a first way of acting would be the following. We need to gather everything that is x related, so 3x and 2x, on the left side. Remember, however, that since all these terms are being added or subtracted, every time we move a term from one side to another, the sign of that term should change. So we should move all the yellow ones or the variable parts 3x and 2x on the left, but 3x was already on the left, so nothing will change. 2x, however, it has to turn from the right side to the left side. So its sign is going to be different. So we can write 3x minus 2x. Then this is followed by the equal sign. And now everything else, meaning the constants, meaning in this case, the 5 and the 11, should move respectively on the right side. Neg 5 was on the left. It will move to the right by changing its sign. It's going to be minus 5 plus 11. Now we will have to add like terms, meaning that we need to simplify. 3x minus 2x, it is equal to 1x. Minus 5 plus 12, it is equal to 6. If we want, we can divide both sides by 1, or we don't actually need that in this case, but x would be equal to 6. Let's see a second example. Solve minus 2x plus 10 equals 8x minus 20. Once again, I'll begin by visualizing an imaginary number line that can be seen as a boundary between the left and the right side. Again, I need to bring all the variable parts. Let me highlight them by yellow. I need to bring all those at the left, and I need to bring all the constants, all numbers, at the right. I need to do what we call separate knowns from the unknowns. I can easily do that by remembering that every time one term moves from one side to a different side, its sign should change. So minus 2x was already at the left. It remains at the left. Nothing changes. But regarding 8x, it was originally placed at the right. Now it will turn to the left, which means that its sign should change. Equals, the same goes for 10. It was at the left. It will now be found at the right. So it's going to be negative 10 minus 20. And then we need to just simplify the like terms. Minus 2x minus 8x, it is the same as negative 10x. Negative 10 minus 20, it's the same as minus 30. And then finally, to get rid of the negative 10 and therefore solve for x, I will divide both sides by negative 10. So negative 30 over negative 10. These 10s are cancelled out and we are left with x. Negative 30 over negative 10, it's 3. And that is exactly the solution to that. Let's do one final example, but I'm sure that by now you have all understood the process. 5x plus 3 is the same as 6 minus 7x. Again, I'll begin by drawing the imaginary boundary between the two sides. And again, I will highlight the constants by blue and the variable parts by yellow. Of course, during an exercise, an actual exercise or an assessment, or when solving homework, you don't need to highlight all that. We're doing math. But this is just for us here to help us visualize the whole process. Remember now that all the yellow ones should move on the left. 5x was already on the left, so it will be still there. Nothing will change. But for negative 7x, since it has to move from the right to the left, each sign should be different. So it's going to be plus 7x equals plus 3 should move from the left to the right. So it's going to be minus 3 plus 6, which still remains at the right side. Then I need to simplify. 5x plus 7x, it's the same as 12x equals 3. And finally, I need to divide both sides by 12 so that x is left by itself. 12 over 12, they cancel out, and we are left with x being equal to 3 over 12. You can easily leave it like that. I hope this video helped you at least a bit to understand how these first degree equations work. In case you still have some issues, please don't be shy. Leave your questions below this video in the comment section. As always, thank you for your time and thank you for watching.